Welcome back to Python for AI and Machine Learning. I am Dr. Azad Rasul, and this lecture we will jumping into running TensorFlow and PyTorch models in the cloud using Google Colab. In the previous lecture, you will set up Google Colab and run a simple script. Now, we are taking it up a notch by training actual AI models, like neural networks for classification, using Colab's free GPUs and TPUs. Today, we will run TensorFlow and PyTorch models, see how cloud computing speeds things up, and get you ready for projects. Let's dive in. First, running a TensorFlow model in Colab. Let's train a TensorFlow model in Colab. We will build a neural network to classify synthetic crop health data. For enable GPU in Colab, runtime, change runtime type, and choose GPU, save. Let's explore this TensorFlow code, which trains a neural network to classify data, like predicting if a crop is healthy or unhealthy, based on features such as NDVI. Think of the neural network as a smart assistant that learns patterns to make decisions. This code runs in Google Colab with GPU power. It is a stepping stone to projects like crop health prediction. We will break it down step by step so you can understand every line and try it yourself. Generating sample data code block. First, we import libraries, TensorFlow or TF for building neural networks, NumPy for math operations, and make classification from sklearn to create fake data. Imagine we are studying crops, and our data includes two features, like NDVI and soil moisture, to predict if a crop is healthy or not. The make classification function generates 1000 data points, number samples equal 1000, with the two features, number features equal 2, both useful for classification. N informative equal 2. We set redundant number and number repeated equals 0 to keep it simple, and number class equal to creates two categories like healthy or unhealthy. The random state equal 42 ensures the same data every time. Think of X as a spreadsheet of crop measurements like NDVI and soil moisture, and Y as a column saying healthy, 1, or unhealthy, 0. It's like preparing data for a crop health report. Second part of the code, building the neural network. Here we create a neural network using TensorFlow's tf.keras.sequential, which stacks layers like building blocks. Think of the network as a brain that processes data to make predictions. Our model has two layers. The first layer, tens equals 16, activation equal ReLU, input shape equal to takes two input features, for example, NDVI and soil moisture, and connects them to 16 neurons. The ReLU activation helps to model learn complex patterns by ignoring negative values. The second layer bends one activation sigmoid, reduces the 16 neurons to one output, giving a probability between 0 and 1 using the sigmoid function. The input shape equal to tells the model to expect two features. This setup is like a mini decision-making system for classifying crops. The neural network is like a librarian storing books. The first layer scans two book details to find 16 clues. And the second layer decides if the book belongs in the good or bad file output. Compiling and training the model. Now we set up and train the model. The model.compile steps pairs the model with three parts. Optimizer equal Adam. The Adam optimizer adjusts the model's weights to improve predictions like a coach tweaking a game plan. Loss equal binary cross entropy. This measures how wrong the model's predictions are for our binary task. It is like a score of how far off the model is. Metrics equal accuracy tracks the percentage of correct predictions during training. The model.fit trains the model by feeding it x and y for 10 epochs, meaning 10 pass through the data. The batch size equal 32, process 32 data points at a time, making training faster. In Colab's GPU environment, this runs quickly and you will see accuracy improve with each epoch. And we can change this epoch number to find high accuracy. Training is like teaching a robot to sort apples. The optimizer adjusts its sorting rules. The loss scores its mistakes, and each epoch is a practice round to get better. Evaluating the model. Finally, we check how well the model performs with the model evaluate. It runs the model X and Y through the trained model, calculating the final loss and accuracy. The accuracy, like 0.92, means 92% of the predictions are correct. Pretty good for a simple model. This is like testing if our crop health predictor correctly identifies healthy against unhealthy crops. Evaluation is like grading a final exam. The accuracy tells us how many crops the model correctly classified, like getting 92 out of 100 questions right. This TensorFlow code trains a neural network to classify data, like predicting crop health, using Colab's GPU power. It's a foundation for projects in the coming model, where you will building a crop health predictor. Try the coding to experiment with this code and share your results in a Q&A forum. Let's keep mastering AI with a PyTorch next. Now we run the script. Epoch 1 to 10. The accuracy from epoch 1 starts from 0.33, then increased. Finally, accuracy is 0.86. Let's change epochs from 10 to 100, for example. GPU, it just running in a few seconds. The final accuracy is 0.89.